Hey, my name is Arjun Verma, and I'm going to be working on the Week 4 preview. So the main physics idea for this week, I would say, was that we learned a lot about how to apply like the basic formulas and objects in motion with velocity, as well as things like the spring constant and just how forces act on objects in general, as well as how forces act on objects in motion. I learned about Hooke's law. That's something I didn't know, and I found very interesting. Is how spring can like activate a force and like move something forward. And I also learned about how to apply like the general velocity equations and force and acceleration to objects in motion and see, how long something stays in the air, how long something moves, how that's affected by vectors, how momentum changes and how impulse can change momentum, and how impulse is equal to force. So like the change in momentum is equal to the change in momentum over time is equal to the change in force, because like impulse is the change in momentum, and that's equal to force applied, as well as acceleration changing. So as well as this, thing that really sparked my curiosity was how impulse works and how the change in momentum, if it's like instant, is still like impulse, even though since it's instant, it should theoretically, like if velocity immediately changes direction, the acceleration should theoretically be infinite because it takes no time to do that. But it's not, because impulse is the change in momentum, and the change in momentum is equal to force. So I found it pretty interesting because it kind of like changed the way I thought about acceleration and force. And I also found that topic kind of difficult, so I went on to it afterwards and checked videos about it. And the other thing I found difficult was seeing the change of momentum over time and regarding that with angles and seeing how that could affect like certain things and how that change of momentum could affect stuff. I found interesting, and I found pretty like useful because it made me think more about vectors in regards to momentum and forces. And yeah, I enjoyed it. And the supplemental research I found most helpful again is Khan Academy. I like all their physics videos, and I think they're great. Yeah, thinking more about momentum, I really would like to work more on those problems where like balls bounce and like interact with other objects, because that's another thing that sparked my curiosity and made me like think a little bit more, is like how objects interact and how friction and all those other things apply. So I'm curious and interested to learn more about that when we eventually learn about friction and to apply those formulas. I find it interesting that we have like a small set of formulas, because like in high school we had a gigantic set, but here we have less and we just have to derive them on our own. And I also find that a lot more fun, especially when I was doing the homework. Deriving my own formulas was really interesting, and I enjoyed it a lot more than just working normally. Yeah, I guess another thing that I learned that I didn't know was for the Hooke's law, the spring formula, I didn't realize you had to put the L hat on the end to identify direction. I was very confused as to what that was until I like reviewed the lecture and made sure I knew it was direction. Um, yeah, and how that affects the spring constant and how to make sure that my units are correct, especially when you have spring questions that are in centimeters, and I have to make sure, okay, that's 100th of a meter and 100th is a 0.0x. Um, yeah, and that was what I learned about this week's physics idea, and I enjoyed it. Um, yeah, I had a good time working on these problems, and it did kind of relate to my own area of study because I do research in robotics, and seeing how all these objects interact would be useful for how robots interact with the environment. And although the math's a lot more complicated there, we don't really look at the physics. It'd be cool to look at the physics. Thank you.